Here is a fact about the universe that Richard Feynman called impossible to explain in terms of anything you have ever seen before. If you fire electrons one at a time, not a beam, just one, then another, through a barrier with two narrow slits, they land on a screen behind it and build up an interference pattern. Bright bands, dark bands, like ripples from two stones dropped into a pond at once. The electron, apparently, went through both slits simultaneously and interfered with itself. Now maybe you say, fine, electrons are waves. Water is waves, sound is waves, light is waves. Waves go through both slits. But here is the problem. When the electron actually lands on the screen, it lands at one definite point. A single dot. Not a smear. Every electron, one specific location. After 10,000 electrons, the dots form the wave pattern, but each individual electron still hit a point. Something wave-like traveled. Something particle-like arrived. The same thing did both. This is not a wave. This is not a particle. It is something for which we have no everyday name. So you ask a perfectly reasonable question, but which slit did it actually go through? You put a detector at the slits, something gentle, maybe a single photon bounced off the electron just to tag which way it went. And here is the part that troubled Einstein for the rest of his life. The moment you detect which slit the electron used, the interference pattern vanishes. Two bands, not the wave ripple. The measurement changed the result. The electron, somehow, knew it was being watched and behaved differently. Feynman's answer was not to explain why. He was honest, there is no deeper why that physics has found. His answer was a rule, a recipe. You add up every possible path the electron could take from source to screen. Every path, no matter how wild, contributes a tiny complex number, a number with a size and a direction, like an arrow spinning in an imaginary plane. Nearby paths tend to point the same direction and reinforce. Distant paths point every which way and cancel. What survives tells you the probability of finding the electron at each spot. This is called the path integral, and it is the most accurate physical theory ever tested. Notice what Feynman did not say. He did not say the electron decided. He did not say it split. He did not say it was in two places in any ordinary meaning of that phrase. He gave you a calculation, and the calculation works. But it carries an implication we tend to slide past. We assume that if something exists, it has properties at all times, a position, a path, a definite answer to which way did it go. The double-slit says that assumption is false. Before the electron is detected, its path is not hidden from us the way your keys might be hidden under a cushion. It simply does not have a path. Feynman said the double-slit experiment contains the only mystery of quantum mechanics. Not one of many mysteries, the only one. Every other strange result, superposition, entanglement, tunneling, the uncertainty principle, is in some sense a variation of this. If you understand the double-slit, really understand it, which means sitting with the discomfort of it, you understand the shape of the puzzle. And if you still feel, after all of that, that you do not quite understand it, Feynman would tell you, that feeling is the understanding. Welcome to quantum mechanics.